Hello everyone, this is Professor Chan for Math 1245 speaking. Today we're going to be going over section 3.3. And 3.3 talks about two different types of division. One is long division and the other one is synthetic division. Some of you guys coming into this may already know how to do some of these types of divisions, but we're going to go over them and their necessary tools for the next section, which is 3.4. So let's get started. So when I'm doing, so let's say you're being asked to do long division right here, okay? And sorry, I do apologize that I did not write that in the packet. Let's say you're being asked to do long division, okay? One thing to keep in mind is when you are being asked to do long division, sometimes they write it in a fraction form, and then sometimes it's already in the long division form. So if it's in fraction form, the way that's going to be written is your top number or your top object will be written inside, and then your denominator will be written on the outside. So I'm saying x squared plus 8x plus 15, I'm dividing it by x plus 5. Okay? So how do we do long division? So the first thing before I get started is I want to see that everything is written in standard form. And remember, standard form is going from highest degree to lowest degree. And then for both my dividend, which is the stuff inside, and my divisor, which is what I'm outside, right? So both of them are going down by 1 degree. Yeah, so they're all going from largest to smallest, and then they're all, more importantly, is going down by 1 degree, which is true. So let's take a look at this right here. So how do I divide? So I look at my first term for my outside, and I look at my first term inside, and I want to see what I multiply x by to get to x squared. So I'm like, okay, well, x times x would give me x squared here. So that means whatever I write on top, now remember, think about like regular long division. Whatever you put on top, that's what you multiply what you're dividing by. So since I put x on top, I'm really doing this, x times the quantity x plus 5. And I'm going to distribute this. So I have x squared plus 5x, and then I subtract just like what we do in long division. Now we have to be careful because we're subtracting both of them. I'm subtracting my x squares, and I'm subtracting 8x minus 5x, and that gives me 3x here. Okay. Now what I'm going to do, just like regular long division for numbers, is I'm going to bring my 15 down, and I'm going to repeat once again. So I'm going to look at my x and see what I would multiply x to get to 3x, and that will be 3. This is 3x plus 15, and then I can subtract this here as well. Okay, I have no remainder, so my solution is just going to be x plus 3 here. Okay, so that's it, and we're going to start on another problem. So let's take a look at number 2. Okay, so we're going to do the same thing right here. So x plus 3 is going to go on the outside. Now let's take a look at this here. So our rule is when I put my numerator inside, it has to be in order, but it also has to go down by 1. So notice I have x cubed, x squared, and it jumps straight to a number. I'm skipping x. Okay? And the reason why we're doing this is I want to actually have everything go down by 1. So what I'm going to do is I'm going to insert 0x. Okay? And I'm doing that, like obviously we don't have an x, but I'm doing that as what's called a placeholder. So everything's just going down by 1. So there's no weird jumps as through my dividend, which is the items inside my divisor sign. Okay, so inside my division sign, right, notice everything's going down. It's going down by 1. 3, 2, 1, 0. The degrees are going down by 1. Okay, and then same with my divisor, it's going down 1, 0, which is fine. Okay, so let's take a look at this here. What multiplies x to get to 2x cubed? That'll be 2x squared. Okay, and then I can multiply 2x squared by x plus 3. Now, notice what I'm writing on the right here. You don't necessarily need to do this. This is good practice, but as you get better in this, this part is not necessary where you're multiplying it out. You can kind of do this in your head. Okay, but I have 2x cubed plus 6x squared, and I'm going to subtract. And I have x squared, and I have plus 0x. Okay, as a placeholder. Now, I'm going to think about what multiplies x to get to x squared. So it'll be x so I subtract, and I have negative 3x, and I bring down negative 20. Be really careful when you're subtracting. Remember, this negative applies to both, right? It applies to the x squared and applies to the 3x. Okay, you don't want to say it's 3x as your result. You don't want to say 0 plus 3x as your result, because then you're saying x squared plus x squared. Okay? So, let's look at this here. And then I have negative 3. And I have negative 3 times x plus 3. And I have negative 3x minus 9. Okay, and once again, be very careful when you subtract. So it's negative 20 minus negative 9. So it's really negative 20 plus 9, and that would be negative 11. The way I'll write my solution is my answer is 2x squared plus x minus 3. Now I have a remainder left over, and I have negative 11 over x plus 3. Okay? And remember this too, the top, right, this top number should be a remainder in that it should be a smaller than degree on the top than on the bottom. So we're okay, right, because 11, right, is degree 0, x is degree 1, so that's appropriate, right? I can't have something like x cubed on top and x on the bottom, okay? Okay, and then before we move on, right, just want to understand, you want to kind of understand the general format of long division. So one thing that you should realize is everything should kind of line up, right? So if you notice, whenever I'm subtracting, they always have the same degree, right? Otherwise, you wouldn't be able to combine them, right? So I notice I have 2x cubed, it's 2x cubed, x squared, negative 3x, 3x, right? And things will just naturally kind of cancel out as I'm going from left to right, okay? If that's not happening, right, if I have different degrees, then I'm doing something wrong. A big thing too is you want to keep in mind is notice also your top here. Your top is also in standard form. So it's always going to go from highest degree to lowest degree. So you shouldn't have something like you're starting off with x plus x to the 4th plus x cubed, right? It shouldn't jump around. You always go from highest degree to lowest degree. Okay, so let's look at one more example. Yeah, and then last thing, be very careful. Sorry, before we move on, just be very careful with your subtraction. So I have negative 20 minus negative 9, and that will be negative 11. Okay, so be very careful with your signs. Okay, so let's take a look at one more, which is number 3 here. So the bottom part, notice I have 3x squared plus 1. I need to insert a 0x, okay, because just like for the top part, right, I want to make sure it's in standard form and it's going down by 1 degree. Now the top part here, I'm going to have 18x fourth plus 9x cubed plus 3x squared. I do want to kind of keep going. Yeah, I do want to keep going till I hit to 0. Okay, so I'm going to put 2 placeholders here. You'll kind of see the reason why I'm doing this. Although if you don't include it, it's not technically necessary. It's just more necessary to have placeholders in between. Okay. So let's take a look at here. 3x squared times what equals 18x to the fourth? That's going to be 6x squared. If you have problems multiplying, right, multiply your numbers. So 6 times 3 is 18, and then x squared times x squared, 6 to the fourth. So you multiply your letters separately, and then your numbers separately, and then see if it works out together. Okay, so this is 18x to the fourth. This is 0, x cubed. This is 6x squared. I'm going to subtract. I have negative 3x squared. Okay. Now, sorry, I have 9x cubed and negative 3x squared. And I'll bring the 0x down. So, 3x squared times what gives me 9x cubed? That will be 3x, okay? Now, we are definitely, now even if we might be wrong, at least we know we're kind of in the right direction, because notice I have a degree 1 less than my predecessor, okay? So, 3x times 3x squared is 9x cubed plus 0x squared plus 3x. And then once again, too, notice when I'm subtracting, I have the same degrees, which is good, right? If I have different degrees, then that's problematic. So I'm subtract, this cancels, I have negative 3x squared, 0, and this is negative 3x. And I'll bring my 0 down. And this one will be negative 1. So I have negative 3x squared plus 0x minus 1. I subtract, I have negative 3x plus 1, okay? And that's my remainder. Now, some of you guys are probably wondering, like, that's a really weird remainder, right? Most of my remainders are usually a number. Notice I have negative 3x plus 1, okay? Now, remember, we talked about this here, right? My solution is 6x squared plus 3x minus 1, okay? Now, even I may have a really strange remainder. Remember what I'm putting on top of. I'm putting it on top of 3x squared plus 1. So my degree on top is smaller than the degree on bottom, and that's fine. So that's why it's okay for that to be a remainder. Okay, now if it's 3x cubed, that's a different story. Or 3x squared, I can't do that, right? I have to keep dividing. Okay, but since x is smaller than x squared, we'll leave it as it is, and then this is your final answer. Okay. So that's pretty much it for long division. If you have questions, feel free to send me an email or post in the discussion forums. But we're going to talk about something called synthetic division. Let's talk about how synthetic division works, okay? So synthetic division is really nice because it's actually a lot quicker than long division. But there are some small things that you have to be mindful of. Please write this down. So synthetic division only works if you are dividing by x. Okay? So, for example, if I'm dividing by x squared plus 5, if I divide by, like, x cubed minus 5x, if I'm dividing by x squared plus 7 minus 7, right, these will not work, okay? So, because, right, all these have degrees more than 1, okay? So, at most, it can only be, like, x plus 3, x minus 2, and so forth, okay? So if I'm dividing by x squared plus 5 or x cubed minus 5x or whatever, I have to resort to long division. So synthetic, okay? And so once again, synthetic is only dividing by x plus or minus a number, okay? Sorry. Okay, x plus or minus a number, okay? So let's look at this example for synthetic division, okay? So if I'm doing synthetic division, this is what I'm going to do right here. I'm going to do the following. So I'm gonna draw this little like corner, okay? And what will be in this corner? It's going to be the opposite of x plus 2. So remember, this is called your factor. Your 0 is x equal to -2. So I'm going to put my x value here, -2. And then what I'm going to do is I'm going to write the coefficients, right? Coefficients, if you guys don't remember, is a number in front of your x. And it's going to be, so I'm going to do x cubed is 1, 5x squared is 5, 7x is 7, and then 2. Okay, everyone see that? So I'm just writing I'm writing the number in front of each of those degrees, okay, from largest to smallest, okay? So this is what I'm going to do now. I'm going to drop my 1 to the bottom, and I'm going to multiply it by the number inside my corner, which is -2. So I'm like 1 times -2 is -2. And then I combine this with the number on top. So I say 5 plus -2 is 3. 3 times, and then all I'm going to do is going to repeat the same thing over. So it drops down. I multiply. 3 times -2 is -6. And I repeat again. Then I combine. 7 plus -6 is 1. 1 times -2 is -2. And I have 0. Okay. So what does this little corner here mean? This is your remainder. So in this case, I don't have a remainder because my remainder is 0. Okay. Now, what I'm going to do is once I'm done, I can convert this back into a polynomial. This will turn into x squared plus 3x plus 1. Okay? So I kind of take these numbers and I write them back in terms of their degrees. Here's the thing too. If you don't understand which degrees it aligns with, okay, the easiest thing is to look at the number next to your corner. This right here is degree 0, and then you'll just go up as you go to the left, right? So if this is degree 0, this has to be degree 1, this has to be degree 2, okay? So degree 0 is always the one like right to the left of your remainder. Okay. Okay, so let's do another example right here. So negative x minus 1, what I'm actually dividing is x is equal to 1. My apologies, let me redo that part again. So it'll be 4, -3, 3, -1, and my x is equal to 1. Okay. So I'm going to do the following here. Sorry, let me redo this again. So let me redo this part again here. So I have x is equal to 1, 4, -3, 3, -1. So I'm going to drop the 4 down, and I'm going to multiply it by 1. It'll be 4. 4 minus 3 is 1. Sorry, -3 plus 4 is 1. And then I repeat, 1 times 1 is 1. 1 times 3 is 4. 1 plus 3 is 4. 4 times 1 is 4. -1 plus 4 is 3. So this is 4x squared plus x plus 4. And then I have a remainder of 3 over x minus 1. Okay. Yeah, and then the trick is look at towards what your remainder is and then go up by 1 degree. So the first one's 0 and it goes up by 1. So let's take a look at, for example, number 5. So number 5, let's take a look at this right here. I'm dividing by x minus 1, so so my 1 is going to be in my corner. Now I have to be a little bit careful this time right here, because if you notice, I have missing terms, right? So notice it's not in standard form either. So just like long division, I'm going to insert placeholder. So x to the 5th, I have 1. I don't have x to the 4th, so that's 0. X to the cube is 1. I don't have I don't have an x squared, and I don't have an x, but then I have a negative 2. So let's do the following here. Bring the 1 down. 1 times 1 is 1. 0 plus 1 is 1. Now repeat, right, over and over. So 1 times 1 is 1. 2. 2 times 1 is 2. 2. 2 times 1 is 2. Combine. 2 times 1 is 2. This cancels. I'm left with no remainder. So, and then remember, this is degree 0. 1, 2, 3, 4. So it's going to be x to the 4th plus x cubed plus 2x squared plus 2x plus 2, and that's my final answer right there. Okay? I don't have a remainder, so I don't have anything left over. Okay? Okay? So let's look at one more example. And let's look at this one here. So 2x cubed plus 7x squared plus 9x minus 20 it will be 2, 7, 9, negative 20. And I'm dividing by negative 3 this time. And then I draw a horizontal line. Bring the 2 down. 2 times negative 3 is negative 6. 7 plus negative 6 is 1. 1 times negative 3 is negative 3. 9 plus negative 3 is 6. And then 6 times negative 3 is negative 18. Okay. One thing too is be very careful with this in long division, right? Long division, you're just subtracting each one, but notice with synthetic, you're just combining them, you're actually adding them together. And so this is negative 38. Yeah, so make sure you don't get that confused. And then it'll be 2x squared plus x plus 6 minus 38. And I write this all over x plus 3. Okay. Let's just do the very last one so that we'll call it a day. Okay. By x to the 4th minus 256 divided by x minus 4. So this will be 4 right here. Now, because I don't have an x cubed, that will be 0. I don't have an x squared, that's a 0. I don't have an x, that's a 0. So x fourth, x cubed, x squared, x, and then negative 256. So bring the 1 down. 1 times 4 is 4. 0 plus 4 is 4. 4 times 4 is 16. Bring the 16 down. 16 times 4 is 64. 64 plus 0 is 64. 64 times 4 is 256. Combine them, I have 0. So this is, now look at your first number, that's your 0, and then you can go up, right? So this is 16x, and then this is 4x squared, and this is x cubed. We don't have a remainder, so we're good, and that's our final answer. Okay, so we're going to end here. This is 3.3. Again, if you have questions, feel free to send me an email or discuss on the discussion board. Okay, but other than that, I will see you guys later. Take care.